React Native developers, this swiping user interaction is an absolute classic when building a mobile app. I hope you are well. William here, recording from beautiful Zurich, Switzerland, and this fun user interaction is a perfect opportunity to harness the fundamentals of React Native Gesture Handler and Reanimated. First, let's have a look at the transformations we need to apply, and then we will focus on handling the gesture. We have our cards and we overlay them on top of each other using an absolute fill. Now, the first transform we would like to apply is a slight rotation on the x-axis to give it a nice 3D effect. However, you can tell that this looks a bit strange. Why is that? If I draw lines across the corners of the card, we always get a rectangle. This is because we are missing the perspective transformation. The perspective will add a simple projection of the 3D points onto the 2D canvas, so points which are further away will look smaller. We add our perspective, and now the lines across the corners of our cards have become a parallelogram, and it looks much better. You can, of course, adjust the value of the perspective to your needs. The next transformation we would like to apply is a transformation along the z-axis. Here we want to use a random value, let's say between -10 and 10 degrees, to give it a nice effect of the cards being stacked on top of each other. Another transformation we would like to add is scale, so that when we select the card, it grows a little bit bigger. Here we use 1.1, meaning that the card will grow 10%. We can also move the rotation on the x-axis to 0 when selecting the card to give it this nice effect. And finally, we would like to move the card around. We use translate x and translate y for that. Our transform is now defined, and now we build a small pan gesture handler to drive the values of the transformation. We create an animated gesture handler from Reanimated 2. When the gesture is active, we assign the translation x and translation y value to the x and y coordinates of the card. Now, translation x and translation y will always start at 0 when the gesture is active. This means that when starting the gesture, we need to remember the position of the card. For that, when the gesture starts, we store the x and y value into the context object. The goal of the context object is to provide a state that is available across different states of the gesture: on start, on active, on end, and so on. Now that we remember the position, we simply add it to the translation values. And now our cards should translate nicely. Finally, when the gesture ends, we need to snap the card either to the left, right, or back to the middle. Redash provides us with a nice function named snapPoint to tell us where to snap the card when releasing the gesture. And we can simply spring to that snap point destination. For the y-axis, we can always snap back to 0. Now let's jump into VS Code. I have a boilerplate project which you can download in the video description in case you want to code along with me. And I think the first thing we're going to do is to wrap the card component to have a pan gesture handler, and we're going to add a translation on the x and y axis. So here I have the view which I can wrap with a pan gesture handler from React Native gesture handler. And the first and unique child of a pan gesture handler needs to be an animated view from Reanimated 2. So probably need to import it here. Up. So I want the one from Reanimated. I appear to have an animated view. Okay. And we can add our animated gesture handler. So on gesture event, and we're going to create our animated gesture handler. So on gesture event, use animated gesture handler. Now I'm going to create two animation values, one for the translation X and one for the translation Y. So I can create X is use shared value and Y is also use shared value. Now when the gesture is active, on active, we get the translation X and Y, and we can assign it to the X and Y animation value. So X.value equals translation X and Y.value equals translation Y. Now we need to apply these values to the style, so via a transform. So we're going to create an animated style, use animated style. We're going to return a transform, and here for now we're going to add translate X, so equals X.value, and translate Y equals Y.value. And I can assign the style here. So now I can translate the card nicely. But if I start the gesture again, because translation X and translation Y always starts at 0, it always goes back to 0. So we need to remember the position when we start the gesture. And this is where we're going to use the context from the gesture handler, where we can keep states across different states of the gesture. So on start, we're going to get the context object and save the X and Y value. So X equals X.value and Y equals Y.value. Now I can add the type for it here. So the first generic parameter here is going to be which type of gesture it is. So here it's spine gesture handler. And here in the second generic parameter, I can type the context. And so my context is very simple. I have X and Y value. All right. So here I remember the values. I can keep the state on active. So across different state of the gesture, I can access the object. So I'm simply going to add this value to translation X and translation Y. Here I'm moving the card around. I release. And when I start again the gesture, it remembers where it was. So it moves nicely. Now, when we need to release the gesture, we need to snap either back to the middle or to the left or to the right. So we're going to create a variable called destination. So we need the X.value, we need the velocity. So I need velocity X and velocity Y. In here, we're going to use velocity X. And we need the list of snap points. So if we go look at the list of snap points, here I used the width of the screen, which is way too big. It's actually, let me call it maybe side. So side, we could do half of the width. Maybe I can just rename this one here. So half of the width and half of the width of the card. Because the origin is the center of the card. So here I have card width. So I could do card width divided by 2. I would be. So we go minus plus side or 0. That looks good. Let's have a look. So here we have the destination. We can spring to that destination. So with spring to destination, and we can use the velocity in the configuration. Let me import with spring. And for Y, we always go to 0. So with spring to 0, and we can use velocity Y. Let's have a look. I need to fix I move the card around. So here the snap point is not correct. So the width of the screen minus the width of the card. No, it's plus the width of the card divided by 2. So here I snap back to the center, and if I go left, so it's not the minus the width of the card, but plus the width of the card divided by 2. So up, back to the middle, and let's go to the side. Perfect. So here we see the bouncing appear on the left and right. So I think we're going to add some padding to this, maybe 50 points. Let's see. So that actually looks good. Now what I would like to do is to add the rotation on the X and Z axis. And we can add the X rotation because it's fixed, maybe let's say 30 degrees. So rotate Z equals 30 degrees. No, rotate X, sorry. And you see it looks squished because we didn't add the perspective. So we can add some perspective value. Here you can pick look, whatever feels good to you. So this looks good. And what we can do, so we're going to add the scale transform, but first maybe let me do the rotate Z. So we're going to add a rotate Z value. And we want a random value between, let's say, minus 10 degrees or between minus 10 to 10 degrees. So we have math random that goes from 0 to 1. So we want it to go from 0 to 20. So we multiply by 20, and then we remove 10 to go from minus 10 to 10. Right, we go from 0 to 20, and if we remove 10, we go from minus 10 to 10. And we can apply this transformation. So rotate Z equals rotate Z dot value, and these are degrees. Looks good. And now one thing we can do is when selecting the card, scale the card, have the rotate Z go back to 0. So I'm going to add the scale transformation. You'll notice that here I'm adding the scale at the end. Here the order of the transformation is important. I will link to a video on this topic in the video description. So we're going to create a scale value. So use shared value. Default value is 1. When we start the gesture, we can put it to 1.1, so plus 10%. And rotate Z goes to 0. And we probably can add maybe some nice easing to give it a physical feel. Let me import easing from Reanimated. So here I select the card, the rotate Z goes to 0. We scaled nicely. I need to scale back when we release the gesture. So on end, scale.value goes back to 1. And I think I should always use this easing in the animation configuration. And one thing we could do is also set the rotate X to 0 when we select the card. So that actually looks pretty good. And one thing we can do is to animate the cards when they appear for the first time. So the default value here for Translate Y is going to be, let's say, minus the height of the screen, so they disappear. And we can add a use effect. So when we mount the component, we want the cards to appear. So let me add the empty dependencies. So we can add, so y.value, we can add the timing animation to 0. Again, yeah, here I have duration, and I want to use some nice easing. But of course, we want, here they all appear at the same time, we want some delay, which depends on the index of the card, which we have as a property here. So I'm going to calculate delay is simply index time duration. And so here we can add with delay. So what I like in Reanimated 2 is that animations are first-class citizens, and they can be nicely composed with each other. You can add delays, timing, and you can really actually go pretty crazy with the level of composability in the animation. You can add pause, bouncing, you name it. Here I can update the array of dependencies, even though it will never change. And one thing we might want to do, let's have a look. So that's pretty good, but also maybe we want to set the rotate in the animation. So I'm going to extract it here. Sorry. So I can execute this also on rotate Z to go to theta. And maybe I want to add an offset to the delay, maybe 1 second. Here you can pick any value you would like. Let's have a look. So I think that looks pretty good. And I can swipe the cards. And now when all the cards have disappeared, I would like maybe to shuffle them back with a nice animation. So here, shuffling back is a state that is across all cards. So I need to go to the parent components. So here I have all my cards. And I'm going to create a shuffle back animation value, which is true when we need to shuffle back the cards. So shuffle back, default value is false. And I can pass it as a property of each card. So shuffle back is an animated, so it's a shared value of Boolean. I get it as a property here. And when the gesture ends, and actually we can look when it ends, so it means also when it ends and the animations are over. So I can use the callback here in with timing to see when the animation is over. So the problem is because Spring has small oscillations, even though it looks like the animation is finished, technically it's not done. So with timing will be faster because it's exactly after the default duration, it will be over. So we can look if the card is last. So here, because we had them on top of each other, it's if index equals 0. And if the destination is left or right, so if the destination was 0, we don't need to shuffle back yet. So if index is 0 and destination is different from 0. Then we can set shuffle back to true. And now for each card component, we can listen to the shuffle back animation value. If it is true, we need to animate. So, and for this, we're going to use animated reaction, which lets us listen to a change in animation value and react to it. So use animated reaction on shuffle back. So shuffle back dot value. And here I get it as parameter of the second, but of course we could use shuffle back directly. I mean, I'm not sure, whatever. If value, no, actually, let me just, I think it's much more explicit. I don't know which way is better. So if we need to shuffle back, we're going to set the x value back to 0. So x dot value equals with spring, so to 0. And we want to add some delay. And we want also maybe to add rotate z back to the random value. So rotate z dot value is with spring to theta. So now they will all appear at the same time. So again, we need some delay value here. So here it's a spring. Let me put maybe 150 milliseconds, so time index. So here we can add with delay. And when the animation is over, so here we can look at the callback of either animation. When it's over, I simply want to set shuffle back to false. Sorry, I have some. Yeah. So the second parameter would be the spring config. Here I keep the default, and then we can have the callback for when the animation is over. Let's have a look. So the cards appear nicely. Up, swiping, and you see they shuffle back nicely. Isn't that cool? It feels great. Just a fun example. Guys, I hope you enjoyed this example. These are the fundamentals of gesture handler and Reanimated. We looked at the transforms we need to apply. The transform API in Reanimated is really well done, and I will link to a video on this topic where we can dig further on how this API works. And I hope that it's a topic that we will get to explore in future videos. And then we built a simple pan gesture handler. We use the translation X and Y and the context to remember where we were when we start the gesture. When the gesture ends, we use a snap point function from Redash to know where to snap the card. Let me know what you think in the comments below. I am looking forward to talk to you soon. And until next time, happy hacking.
They say the mountain is the top. I say that just scratch the surface. Yeah, we started at the bottom with no option but to go up. You know what hurt is? When you growing up with no love. When you knew how to die before you learn to hug. When you fought in the street or you pulled a gun and led off at the ops so you sold drugs. Right? Now I'm rolling through the city, living at the top of my world. Living at the top of my world. Waking up to new views in the morning up under my girl. Yeah. This is what it feel like. This is what it look like. When you see it from the top, this is what it sound like. When it came from the heart that could have died on the block.
You don't know my story. You don't know how much my mama worries. Oh, I should tell you by the way, I came for everything. I will not run away, I will not run away. I'm here to stay.
Yeah, they say the sky is the limit. I say that just scratch the surface. You see my lifestyle change. Now I'm high on purpose. Yeah, I'm fly on first class. The last shall be first, yeah, I outlast. Last laughing to the bank with the bag. I remember back then, way back. They was looking at me like I never be nothing, but I already knew. Now I'm pulling up in something cool, popping out so fresh, like looking brand new. This is what it look like. This is what it do. When you're living like the truth, heartfelt like the news, and what I put my mama through. This ain't nothing new.
You don't know my story.
Nothing.
You don't know how much my mama